welcome everyone. I need you guys to confirm if you can see the screen and if you can hear me, okay? Please confirm on the chat box. Please comment if you can hear me. I need to see your comments, guys. Can you hear me? Can you see the screen? Thank you, guys. I see you today. You came in numbers, ne? Thank you for joining. Let's start working. We don't have time to waste, ne? We're going to start with just a quick warm-up question. We're just gonna start with a quick warm-up question because there's something that I want to bring to your attention, ne? There's something that I want to bring to your attention. So now, what we're going to do is that I want us to look at, okay, let me quickly do this. I see your comments, guys, ne? Okay. Let's say I have a box like this. Let me quickly just put this like that. There we go. So now, let's say I have a box like this. Now, I'm going to explain a very important thing here. And let's say on this box, we have something that is applied at an angle. Now, please, guys, make sure that you stay with us until we finish the lesson. Trust me, you're going to enjoy the session. So now, if I have a box, and this box is applied at an angle, so I'm going to write what is the angle. I'll give you all the information and the mass. I'm going to write everything down. So now what I need us to do, let's say this box has the mass of 50 kg, so I'm going to write this as 50 kg. So this is 50 and we have this as 30 degrees. It's applied at 30 degrees and we are given F applied. We are given F applied, which is given as 100 newtons. Okay, so now this is what is given. We have a crate of mass 50 kg and it accelerates along a flat horizontal surface. The coefficient of kinetic friction between the crate and the surface is 0.1. So we are given the coefficient of kinetic friction. So this is my UK. It's given as 0.1. I'm just going to put the 0.1 there. I'm just going to put the 0.1 there. Okay. So now, they said that while accelerating, a force of 100 newtons act on the crate of an angle. Please, guys, give me a second. Okay, so now they said that the coefficient of kinetic friction is 0.1 and we can all see that. Then another thing that is given, they say that they want us to determine the magnitude of the force of friction acting on the crate while it accelerates. Now, I'm going to write the question down. We need to determine the magnitude of force of friction. Okay, so now we need to find the force of friction that is acting on the box. Please guys, make sure that you stay with us until the end, and then you're going to tell me what you think about the lesson. So what I'm going to do, remember, we still apply everything that I showed you guys yesterday. Everything that I showed you guys yesterday, we need to apply it on this problem. Remember I said, you look at what is the question saying. Determine the magnitude of the force of friction. So when they want the force of friction, what do? We write the formula for friction down. I hope everyone is with me on that. We write the friction formula down. So I'm going to write my the formula of friction. We know that Fk, the formula for friction is Fk, it's equal to the coefficient of kinetic friction. We need to multiply this by the normal force. I hope you guys can understand that part. So when they want us to find the force of friction, this is the formula that I'm going to do. I'm going to write down the formula, then the formula will tell me what I need to do. It's easy, trust me. It's easy if you do it like this. So because we know that UK is given, the coefficient of kinetic friction is given, it is 0.1. We just have to find the normal force. Then now you need to ask yourself, what is normal force? Normal force is a vertical force. Then you need to draw a free body diagram indicating all the forces that are acting on the diagram. We need to indicate all the forces that are acting on the diagram. I hope everyone is with me on that. Let us quickly do that. I'm going to say I have my normal force acting up. This is my normal force. Then we're going to have Fg going down. Okay, let's do this. Let's just remove the coefficient of friction there. Okay, let us remove this guy here. Then we said that this is my Fg going down. So we are given UK to be equals to 0.1. So now what I need you guys to do, is that on the UK part, we're going to say, look at this. There's that force, remember, we're going to have the force, my horizontal force going that side. Then we're going to have my Fy pointing up. My Fy will go up. So now what I need you to do, I need you to write down all the forces that are vertical. So I have my Fn, it's pointing up. I have my Fy, it's going up. Then I have my Fg. Right. So now we can use Newton's law. Remember what is Newton's law saying? Newton's law says F net is equals to, what is F net equals to? F net, remember these are vertical forces. F net will be equals to 0. Therefore, let's choose. We're going to take up as positive. So if we take up as positive, we're going to add. You need to add all the forces that are going up, because we take up as positive and all the forces that are going down will be negative. So this will be my Fn, which we need to add it to what? To Fy. Then we need to subtract all the forces that are going down. So we're going to subtract Fg and equate this to 0. What is the aim? The aim is to find normal force. So we need to do what? We need to isolate this. We need to say Fn, it's equal to the Fg goes to the other side to be positive. Therefore, we subtract the Fy. So I'm going to put this, let's highlight this just to show that this is the formula that we're going to use to find our normal force. We need to use that formula. I hope everyone is happy with that. So now, what's next? You need to understand that always your Fy is your vertical component And what is Fy equals to as a vertical component? Fy is equal to the force applied multiplied by the sine of theta. Right. So now, what is our Fg equals to? Fg is the weight, it's just the mass times the gravitational force. I hope everyone is happy with that. Ne? So now we have the normal force. Let's take the normal force and substitute it in the formula above. Ne? You know what I'm going to do? We're going to say this will be Fk, it's equals to Uk multiplied by Fn. But look at what is Fn equals to. We know what is Fn equals to, so we're just going to substitute Fn there. We're going to say Fk, it's equals to Uk. Inside the bracket, we need to put our Fg minus Fy. Inside the big bracket, that's what we need to put. But remember, we know that if we say this is Uk, this will be Fg, which is my Mg, minus, we said Fy will be F applied times the sine of theta. So now, why are we doing this, guys? Trust me, you see, if you do physics like this, né? If you do physics like this, there's no way you can get questions wrong. First, manipulate everything that you are currently working on so that you have the correct formula before you do any substitution. You see, when it's like this, now we can substitute because we know what is the mass, we know what is 9.8, we know the F applied, and we know the angle. We can just substitute everything on that formula. We can just substitute everything. Okay, someone is asking, and Tombizot is asking, why F net is not, why F net is equal to 0, not F net is equal to MA. Let me attend to that. Ne? Let me attend the question from Tombizotwa. Tombizotwa is asking, guys, why are we saying that? Why, when we calculate this F net, why is F net equals to 0? Why? Guys, remember, this box, it is in contact with the surface. So if it is in contact with the surface, what is that telling you? It tells you that the magnitude of the normal force is equals to the magnitude of what? Of the force that are going down. So they go in an opposite direction, but they have equal magnitude, which this will make the acceleration, right, the acceleration to be 0. So when we work with vertical forces, I think I did tell you this, guys, yesterday. When you draw a free body diagram and you see that your forces are vertically, just know that this is what? Just know that this is F net is equal to 0. Unless if the object is hanging by a tensional force or something. If the object is hanging, then we can't say F net is equal to 0. But for vertical forces, F net is equal to 0. Why? Because they have an acceleration of 0. I hope this makes sense. Ne? So now it will be easy for us to calculate everything. We just have to substitute what we are given. Ne? We just have to substitute what we are given. So we're going to say our Fk is equal to the coefficient. Look at this. It's given as 0.1. Say, are we allowed to actually manipulate the equation? They normally do not allow us to manipulate. They are very pity when actually allowing us to use this. They make us allow exam guidelines. No. Let me tell you. Okay, it's fine. Ne? I'm going to tell you how they mark this question. Thank you. I don't know what's your name, but I see it's FTBIA7. Constant velocity causing acceleration to be 0. Okay? Because the object is accelerating horizontally, not vertically, so there's no acceleration. Thank you very much. That's very correct. Ne? And Tombi Zoto, if you can read the comments from other learners, you can see that they are giving you the correct answer that you are looking for. Ne? They say that the object is accelerating horizontally, not vertically. So this tells you that there is no acceleration on the y-axis, That's why the F net on the vertical force is 0. You see, you can learn something from your from another learner, you understand? So now, because the object moving at horizontal and there's no acceleration, where the normal force and the gravitational force are vertical, so there's no acceleration. Thank you guys, thank you very much. I want to go back to FTBI. FTBI says that they don't allow you to manipulate. No, they do allow you. Let me show you. You said that they want you to use the formula that you are given where on the formula sheet, and the formula that you are given on the formula is this one, which is F net. It's equals to MA. So there's a mark for allocating the MA as 0. So they'll definitely give you 1 mark for writing that formula. I hope everybody is happy with that, né? So now we're going to substitute. Remember, the coefficient of kinetic friction is given as 0.1. I'm going to put this to be 0.1. Now inside the big bucket, what is the mass? It's given as 50. G is 9.8. We minus the F applied. Look at this. What was the F applied equals to? The F applied is 100 newtons. So I'm going to minus the F applied of 100 newtons. The sine of that angle, which was sine 30. So this will be the sine of 30. We put this inside the bracket. Therefore, the answer that you get, it's your frictional force. So the reason I do my equation first, I'm avoiding to do what? I'm avoiding to round off any answer. I only want to round off the final answer. Thank you, Buttercup. The vertical force are at equilibrium, so the acceleration is 0. Thank you very much. So now, what do you guys get when you put this on the calculator? What is the frictional force equals to? Tomizoto, -1. Where's the -1 coming from? Guys, please be careful when you punch your calculator. Ne? You need to be very, 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 very careful. Remember that the 0.1 multiplies everything inside this bracket. 440 newtons. Someone saying 440 newtons. Did you multiply the 440 newtons by 0.1? Because if you multiply it by 0.1, why did you remove your Maluleke? Thank you, that's correct. Behind her eyes, 44, that's correct. And Tombizota, that's correct. Katleho, correct. 44, guys, 44 newtons. Ne? The answer should be 44. Please, I need you guys to go and practice how to punch, how to use your calculators. This should be the final answer. That was easy, ne? That was easy. So now I want us to do this problem. Ne? I want us to take, let us take, what should we do? Let's take this object, let's change the mass. But now, I want us, okay, before we move, do you guys have any questions? Is everyone happy? Do you guys have any questions? Okay, let's move now. No, for normal force, the direction, for normal force, you can just leave it as 44 newtons. So we only consider direction when we do acceleration. But if you want to put it upward, just to be on the safe case, yeah, you can do it. Ne? Do we indicate direction? It's up to you. Ne? I don't think they'll do a negative marking for you not to saying the normal force is going up. Don't be as because fk is a vector quantity. Calculate what's in the bracket first, then multiply it by the outside number. We good, sir. Thank you very much. Okay, so now let's take let's work on this one. I need us to there's something that I want us to learn. I want us to learn something here. Let's say I have a block, right? So this is my object, but this time let's say the force is pushed at an angle, right? The force is pushed, so it's very important that we indicate that the force is pushed. So this force, you can see the arrow. The arrow is telling you that this force is pushed at an angle. And what is the angle? The angle is given as 60 degrees. Right. So now, I want us to say this is 10 kg. This is 10 kg. You're going to see the difference between, you're going to see the difference when the force is pulled. When it's like this, the force is pulled. Look at this arrow. The arrow is pointing up. The force is pulled. And then on this one, the force is pushed. You need to know the difference when the force is pulled and pushed. Right, I can see, guys, your comments. You choose upwards to be positive and down it's negative. The answer is okay. So now, let's say that this force, we have the force applied. This force applied, let's say it's equal to 100 newtons. Okay, and then another thing that is given, look, they said that the object is pushed at an angle of 60 degrees to the right. Okay, the coefficient of kinetic friction between the box, so we still have the same kinetic friction. The difference is the mass, 0.1, and then determine the acceleration of the object. So the question wants us to determine the acceleration. Guys, we need to be very careful now. Guys, we need to be very careful when we work with this type of a problem. Look at what we are given here now. This problem wants us to find acceleration. I always tell you guys, most of the time when you hear the question says acceleration, the word acceleration, this tells you that this is Newton's second law. So we're going to write the formula for Newton's second law down. F net is equals to ma. Okay, so F net is equals to ma. So if we say F net is equals to ma, this tells you that we need to indicate all the forces that are acting on the object, the horizontal forces. But before that, I want us to indicate all the forces. What I need you to pay attention on is that the Fy this time will go down. The Fx will point in the same direction as what? The Fx will point in the same direction as, how can I say this? Let's do this. The Fx will go in that direction. So this is your Fx and this is your Fy. It's very important for you to know how to identify these forces, the forces that are acting. So if we draw a free body diagram, for horizontal forces, the free body diagram will look like this. I'll have Fx going that side. This is my Fx. Then I'll have my frictional force, which I'm going to call it Fk. So the Fk will go in an opposite direction. So these are the only horizontal forces that are on the object. These are the only horizontal forces. Please pay attention. Don't get lost. Please pay attention. The reason I'm starting with what? The reason I'm starting with this is because they want us to calculate acceleration. So let's choose right as positive because this is moving to the right. It will move in that direction. So I put right as positive. So if we choose right as positive, what do we have now? We're going to say all the forces that are going to the right, we minus all the forces to the left, we equate this to MA. So now remember we can find Fx. So I'm going to calculate Fx. I need to know what is my Fx, which formula am I going to use for Fx, and I also need to know which formula am I going to use for the frictional force, because I have the mass. So if I can find Fx, I can calculate a frictional force, and I can just do the substitution and make a subject of the formula. So what I'm going to do, I'll say that my Fx, look at this, look at what I'm going to do. I'll say first thing first, Fx is a horizontal component which is equal to F applied multiplied by what? The cos of theta. So now what is Fx equals to? F applied is given as 100 newtons. The cos of that angle, which is 60 degrees. I'm not going to use a calculator yet. I'm not going to use a calculator. So now I know what is my Fx. So I'm just going to highlight that guy so that I can remember what is my Fx. So I think everyone understand how we got the Fx. So this is my Fx. What's next? We need to find, if we have the Fx, it's easy for us. We need to find the frictional force. Okay, we need to find the frictional force. So I'm going to write the formula down that we need to use for frictional force. That formula, remember Fk, it's equals to the coefficient of kinetic friction multiplied by the normal force. So now, do we have this UK, the coefficient of kinetic friction? Yes, we do have the coefficient of kinetic friction. We need to find the normal force. Hey, remember, to find the normal force, we need to identify all vertical forces that are acting on the object. So I'll quickly indicate those forces that are acting. I know that I'll have Fg going down, and then we'll have the normal force pointing up. Then we have the Fy this time going down. The Fy is going down this time. So if I draw my free body diagram for the normal force, my free body diagram will look like this. I'll have my Fy pointing down, then I'll have my Fg going down, then I'll have my normal force going up. So we choose up as positive. I'm going to choose up as positive because I need to find normal force. So we need to choose all the forces that are going up as positive. So I'll say up as positive. This tells me that, remember, F net will be equal to what? 0. So these are vertical forces. F net will be equal to 0. So I'll take my Fn, which is my normal force, and subtract all the forces that are going down, equate this to 0. So what do you get when you calculate your normal force? Your normal force is equal to, both of these, they go where? They go to the right hand side, and they will change the sign. So now I know what is my normal force equal to, but now let us pause here. Let us pause here so that I can explain why I wanted us to start with this type of questions. Let us pause here. I need to explain why I wanted us to start with this type of question. So the aim of these two problems is for me to explain what I'm going to explain. I need everyone to listen very carefully, because they'll ask you this question in the answer where they say increase, decrease, remain the same. You understand? So, but we'll do it when we do on the past paper. Yet you are not ready for a past paper because I'm still training you. Yeah. So now look at this. Look at the difference. What was the normal force if the force is pulled? We subtract. So this tells you that we're going to conclude. I'm going to put a very important conclusion. When the mass, look at this, please guys, listen. I hope everyone is listening. When a mass is pulled at an angle, the force has what? Horizontal components and vertical components. So the vertical component reduces the force pushing into the ground and therefore reduces what? The normal force. I think I need to write this down because guys, we are not in a hurry. We are here to learn. Please make sure that you stay with us until we finish the lesson. So now I'm going to conclude. Therefore, we are saying that if the force is pulled at angle, what is this telling us? This tells us that the vertical component, which is our Fy, so Fy, it reduces what? It reduces the force that is pushing into the ground. It reduces the force that is pushing into the ground. Right. So, therefore, we can conclude and say, therefore, this will do what? This reduces the normal force. I need to see this statement on your textbook. I need you guys to write the statement down on your textbook, because they'll definitely ask you this in an exam. They'll definitely ask you this in an exam. Don't worry, I'll show you how they will ask it. It will be where you need to tell us if the normal force will increase or decrease. So we can see that if the force is pulled at an angle, this reduces. So now look at the difference. If the force is pushed, you see now, the force is pushed at an angle. What is happening to the normal force? The normal force increases. We are no longer subtracting Fy, but we are adding Fy. That's the difference. So the difference is that if the force is pushed, the normal force increases. So it will be Fg plus Fy. And if the force is pulled, it will be Fg minus Fy. Simple. That's how I need you guys to understand these things. That's how I need you to understand. So if you can get it like that, everything is good. So now we just know that my Fn will be equals to what? Mg, we're going to add F applied times the sine theta. Okay, so now we know what is Fn. So Fn will be equal to the mass. It was given as 10. So the mass is 10 kg. The mass is 10 kg. Then I'm going to add multiply the 9.8. We add F applied. What is F applied? It was given as 100 newtons. We need to say the sine of 60 degrees. So now I'm going to highlight that guy, because now we have our Fx, we have our Fn. So look at this. This Fn, we need to substitute it there to find what? To find the frictional force. I hope this makes sense, guys. I hope this makes sense. So now I don't like working on this type of questions like this. What I like to do is that I always like putting everything on my equations. I like to put everything on my equation in case I make a mistake, but it's fine. I need you guys to tell me, if we calculate the normal force, let's say we calculate the frictional force, what do you guys get? Because now someone is going to make a mistake when they punch this on the calculator. Remember, Fk is equals to the coefficient of kinetic friction multiplied by the normal force. So this will be equals to, the coefficient is 0.1. The normal force, it's everything here. That is your normal force. This will be 10 into 9.8 plus 100, the sine of 60 degrees. You just have to punch this correctly on your calculator, then you'll see what is your FK equals to. I need to see the comments. Coconut. It's coconut. Thank you very much. You see what you just said? It's correct. When you say, when we separate the... I'm waiting for your answers, guys. Ne? For your answer. Tell me what you get. Ne? Tell me what you get. What is 0.1 multiplied by everything inside the bracket? Coconut. Thank you very much. What you just said now, it's important. Ne? What you just said. Coconut is saying that when we separate the free body diagram, it allows you not to be confused when you have... So now I think everyone can see how easy it is to get a distinction in physics. Ne? Don't worry. Ne? 18.55. So if it... Did you all get 18.55? Guys, you know, you keep making those simple mistakes when you calculate. 18.46. I'm going to take 18.46. Guys, please train how to 18.46 Newton. Guys, I need you to train how to write your how to use a calculator. Ne? So my FK, I'm just gonna write it here. I have FK to be equals to 18.46 newtons. Right. So now we need to find our Fx. Ne? So our Fx, what is Fx equals to? Remember, Fx is 100 the cos of 60. Or you know what? Just leave it like that, because it's going to give you a lot of numbers that will need us to round it off. Let's leave it like that. Ne? So let's substitute what we have. I'm just going to write my Fk and say Fk, it's 18.46. My Fk, where can we write this? This is 18.46 newtons. Let's go and work now. Ne? Let's go and work. So we said Fx, it's 100 the cos 60 degrees. We need to subtract Fk, which is 18.46 newtons. It's equal to the mass was 10A. So now remember, the question said calculate acceleration. They wanted us to find acceleration. So now if we calculate acceleration, this is equals to 10A. It's equal to 100 the cos of 60 minus 18.46. What do you get on your calculator? When you put 100 the cos of 60, what do you get on your calculator? What I'm trying to say is that I need everyone to punch this on the calculator correctly. Ne? Put this thing on your calculator. 100 the cos 60 minus 18.46. That it should be easy for you guys to find it. Ne? Wusisiwe, let's see if we're going to get the same answer as Wusisiwe. Ne? 31.54. So Busisiwe got the answer for acceleration, and Busisiwe is saying that acceleration is 3.15 meters per second squared. Let's see if we get the same answer, ne, as Busisiwe. So someone said this is 31.54. Let's make A subject of the formula. Let's make A subject of the formula. Therefore, what is the acceleration equals to? What do you guys get? 3.154. That's for the answer on the left hand side. So what is your acceleration? Do you guys get the same answer as Busisiwe? 3.15 meters per second. But Busisiwe, what about your direction? Where is the acceleration going? Guys, I see your comment. Thank you very much for participating. Surprise. Maluleke Zintle. Tenjiwe behind her eyes. Oratilwe. Nzondo. Mr. Mustard. Ntomizoto. Beni. Welcome, Fana. Cherofazo. Oratile. Offense. Tabile. Buttercup, Surprise, Tinyeko, Kamorelo, guys, thank you very much. Ne? I can see your comments. Okay, everyone got 3.15 meters per second. So this will be 3.15 meters per second. Don't forget, where is this object going? They push this, it will move to the right. So it should be 3.5 meters per second right. Guys, I really appreciate that. Yes, it's 3.15. Okay, direction is a bit difficult. No, it's not difficult. FT, direction is not difficult. Just look at where is this object going. So they pushing the object, it will move to the right. Guys, I see now. You guys are willing to learn, and this makes me happy. This makes me happy. I see you guys are willing to learn, and this really makes me very, very happy. Okay. Okay, let's prepare the next question. But now, I think everything was easy. The reason that we started with these two questions is for you guys to see that when the force is pulled at an angle, the normal force reduces, the normal force decreases. So this is Fg minus Fy. And when the force is pulled at an angle, the only thing that you need to remember is that Fy will move down, and then to find the normal force, this time we are adding. We are adding, we don't subtract. That's what I need you guys to understand. So you know what we're going to do now? We move on inclined. Let's go back to inclined. Let's go back to inclined and see. I just want to see if you guys will be able to work on this type of questions. Okay, let's say we have a problem like this. Okay, I'm just gonna put my incline here. And someone is asking about the mark allocation. Someone is asking about the mark allocation. Let's go back now. Let's try to do the mark allocation. Most of the time acceleration is 6 marks. Acceleration is 6 marks, 5 marks, 4 marks. So it's more than 4 marks. It's more than 4 marks. But remember, most of the time, sometimes they can just say, calculate the horizontal component. Then you'll get 2 marks for calculating the horizontal component. And then now, they'll say calculate frictional force. Then they'll give you 2 marks for calculating frictional force. So you'll get 2 marks for frictional force. Or maybe 3 marks. That will make this to be 5 marks. Then the last question will say calculate acceleration. So what we did, we just go through everything at once. We just remember the question won't just say calculate acceleration. They'll start asking you questions first. What is the horizontal component? 2 marks. What is the frictional force? 3 marks. Then the acceleration will also be 3 to 4 marks, because there's 1 mark for writing that, and then maybe 1 mark for the correct substitution, 1 mark for isolating the value of A. So approximately what we worked on this problem, it should be around 3, 6, 7 to 8 marks from a past paper. From a past paper. Okay, so now let's do this. I'm going to say I have something like this. Oh, okay. Let's put my inclined here. And then on this inclined, let's say we have a box like that. And then Okay, so we're going to have something like this. Okay, so let's move it more up. Okay. Okay, I'm sorry guys if you don't understand the drawing, but don't worry, I'm going to explain everything now. So this is box P, and we're going to call this box Q, and then box P has the mass of 8 kg, and this box has the mass of 6 kg, and then now this point here to this point here, the height of the incline. The height of the incline. We are given the height of the incline as 4 meters. They say that the height h is equals to 4 meters. I hope everyone can see that. Ne? It's equals to 4 meters. Okay. Yes, I will definitely start with a free body diagram. Ne? Alright, so this angle here is theta. We are given the angle as theta. We're going to call this point y. Okay, it's fine. Maybe we should just name using different. Let's call this y. Okay. This is my y. And then what else do we have? This is my x. This point is my x. And this point here is my y. So, this one, they say that the crate Q of mass 6 kg is attached to crate P of mass 8 kg by a light string which passes over a frictionless pulley as shown in this diagram. Crate P is at rest on the slope. So I'm just going to write this one because it's very important. Crate P is at rest. So crate P is at rest on the slope xy. It's at rest on slope xy. Okay, so now they tell us that when Q is released, it falls to the ground. Ne? This is the first information that we are given. The second information they give us that they say when Q is released, it falls into the ground. Okay, so it falls into the ground and P moves up the slope, accelerating so this one accelerate what at for 0.43 meters per second. So I'm just gonna highlight that because this is something important that we're going to need. The acceleration when it is released, P will move up with that acceleration. So this is the question, but I think the 4 meter, I'm not sure if you guys can see this 4 meter. Okay, let's fix this 4 meter here. The height, it's equals to 4 meter. Okay, we're going to answer the following questions now. We're going to answer the following question. (4.1). Let not say 4.1. Let's call this number 1. So this will be 1. Free body diagram. We need to find I want you to take I need you to work on this, like try to figure out how will the free body diagram look like. How will the free body look like when we have this type of a problem? Let's start with Q, guys. Q is hanging, né? Look at Q. Q is hanging. It's easy for us to do the free body diagram of Q. So I'm just going to name this as Q. So the free body diagram of Q will look like this. So I'm going to draw the free body diagram for Q. So how many forces are acting on Q? We have the force of tension, which will point up, and we'll have the force of what? Fg. So this is my tension. This is my Fg. So what I'm going to do, I'll say that I have my tensional force. And I'll have my, if this is my tensional force, what do I have? I'll have my Fg going down. Are you all happy with that? Yes, thank you, behind her eyes. That's correct, ne? That's correct, thank you. Thank you very much. That is very correct. Okay, so now this is the free body diagram for at Q. Now we need to find the free body diagram for P. Look at P. So when we do the free body diagram for P, look at where is P. So I need you to be very careful on this one, né? So P will have the tensional force. This will be my tensional force that will point up. The normal force going up. This is my Fn. Then since it moves down, the frictional force will go down. This is my Fk. Then it will have the weight pointing down, the force of gravity. So this is my Fg. So those are all the forces that are acting on Q. This is my normal force, and this is my frictional force. And then what else do we have? The tensional force. This is tension. Then we'll have Fg going down. I hope everyone is happy with that, né? So this was 2 marks. This was 4 marks. So in total, 6 marks. Right. The next question says, calculate we need to calculate the magnitude of the tension. And this is 3 marks. Calculate the magnitude of the tensional force. Okay, so for us to do this, we need to say we're going to work on this separately. We're going to work on it separately. So what I'm going to do, even if you don't do it separately, it's fine, because this should be easy. Remember, we can use Q to find tensional force. We can use Q. So in order for us to use Q, I don't want us making any mistake. I'm going to move my free body diagram here and say this is my tensional force going up, this is my Fg going down. So if it's like this, I'm going to say, remember, these are horizontal, vertical forces. F net will be equal to 0. So if F net is equal to 0, but look at this, guys. Okay, when we say F net is equal to 0, this is not true. Remember what we said previously. This one we said F net, the F net is equals to 0. Why did we say the F net is equal to 0? Because the object was on the horizontal surface. But look at this. The object is hanging. It is not in contact with the surface. We can't say F net is equal to 0. So this has to say F net is equal to MA. Even when we are calculating what? A vertical force. F net is equal to MA. Why? Because the object is hanging. You see, this is how I train you. First thing first, I showed you how to calculate the normal force if the object is on the ground. So if it's on the ground, we say F net is equal to 0. But if the object is not on the ground, it's hanging, F net cannot be equal to 0, but it's equal to MA. So what you need to do, we need to choose direction. I'm going to take up as positive. Meaning that, okay, no, let's not take up as positive. Let's see, where will the block Q go? It will go down. I always like to choose the direction of the motion as positive. I always like to choose the direction of the motion as positive. So what I'm trying to say is that, look at this and look at this. We're going to consider, we know that when they said when Q is released, it falls into the ground, so it will go down. I'll take that down as positive, so that all the forces that are going down are positive. We minus all the forces going up, and this will be equal to MA. So we know that this is mg minus the tension is equal to MA. We can just substitute what we are given. Remember, mass, what is the mass equals to? The mass is given as 6 kg because we are using the Q. So this is 6 kg. And then we know that G is equals to 9.8 meters per second squared. And we are looking for tension. And we know that the acceleration was given as what? The acceleration, they said it's 0.43 meters per second. So I'm just going to write my acceleration down. This is 0.43 meters per second. So now I can just do my calculations. I can substitute. So we set mg minus the tension. This is equal to ma. If I substitute, this is 6 multiplied by 9.8 minus the tension is equal to the mass of 6 into 0.43. Therefore, I can bring the tension to the other side. We can take the tension to the other side. What happens? The sign will change. So what I'm trying to say is that the tension will go to the other side to be positive, and this guy will go this other side to be negative. So now we can say tension is equal to what? What will tension be equals to? To find tension, that will be 6, 9.8, we minus 6 into 0.43, and this is equal to the tension. Therefore, when you punch this on the calculator, you should know what is tension. Yes, FT. The statement, no, remember, the statement, they only said it was frictionless pulley. So we do have friction. We do have friction. So now we are working on what? We are working on the object that is hanging to calculate the tension. So we don't consider friction for block Q. So block Q doesn't have any friction. Né? Block Q doesn't have any friction. Zinke, why 56.22? So the tension is equal to 56.22 newtons. Guys, I want to attend some of the questions. Né? I really want to attend some of the questions on the chat box, because I see Zinke here. Zinke is saying that where is Zinke? Say we should have FG going to the left. I'm not sure if I understand why you say we should have FG going to the left. Maybe we are referring to a vertical component. You'll see when we use the vertical components. Né? Just give me a second, guys. I'm going to check all your questions. Before we move to the next question, I'm going to wait and answer all your questions. Né? Okay, let's see. Say, box P, we have FK because there was a movement. Yes, remember they said that. Look at the question. I like what you just asked. What's this? Who's this? Tandeka. Mabitela. Bona. Tandeka, ne? What you just asked now is very important. Tandeka is asking that, are we indicating friction on the free body diagram because box P we have FK because there was a movement? Yes. They say calculate, they said free body diagram of P and Q as P moves up. So we're going to include friction because it starts moving. Né? Guys, there's 54 learners watching now. Please make sure that you definitely subscribe on the channel. Né? Someone asked me today on the TikTok live, how do I benefit the YouTube channel grow? So in order for the YouTube channel to grow, make sure that you subscribe, leave your comments after the recording, and also like the lesson. Né? Don't forget to subscribe when you exit the lesson. Okay. Block Q has no friction. Block Q has no friction because it is lying on a surface. Guys, yes, block Q has no friction because it's not on the horizontal surface. So if we pick direction where the acceleration is not moving, no. Yeah, something like that. If we take, for example, let's say we take up as positive, maybe we're gonna have a negative acceleration. Negative and positive on mechanics is just direction. Yes. Okay, I see all your comments, guys. Let's continue. So now I guess everyone understand how we did the tensional force. Let's move. we're still working on this object. We're still going to answer some of the questions. We still have questions that they want us to answer based on that guy. Let's see. So now what we're going to do, we're going to say this is number 3. Question number. We're going to say this is number 3. Question number 3. Okay, let's put 3 here. Okay, 3. It says that if the frictional force acting on P as it moves up the slope is 13.58 newtons. Determine the angle of the slope, and we also have to find the coefficient of kinetic friction. This is the question, né? This is the question. It says that okay, so they say that if the frictional force acting on P, it moves as it moves up. We are given the frictional force as 13. Guys, I'll try to increase my writing so that you guys can see now. So we are given the frictional force as 13.58. So the frictional force is 13.58, and they say that they want you to determine the angle of the slope and the coefficient of kinetic friction. The angle of the slope and the the coefficient of kinetic friction. So you know what I'm going to do? We are given friction. We need to use crate P. Né? So when we use crate P, I need us to draw all the forces, horizontal forces that are acting on the block. So now, remember, I need you to remember this. Now, always remember this. If I have something like this, and this thing is uninclined, né? If I have this box, and this is box P. So remember, box P will have frictional force going down. I'm going to explain this now. So box P will have the following forces that will act on it. So we're going to say the tensional force is going up. We have Fk going down. We have Fg parallel. Please don't forget that. Always know that if something is on incline, we're going to have an Fg parallel. Please, guys. We're going to have an Fg parallel. So now, when it's like this, I'm going to say Fnet. I'm going to use Fnet. Let me try to increase my drawing. We're going to say Fnet. Nope, this won't work. Okay, we're going to say Fnet is equals to MA. And now remember, we're going to take up as positive because on the previous question, we took down as positive. Né? So this will be up as positive. Why is this up as positive? Our object will move like up, then it will start going down. So we took down as positive, we are forced to take up as positive. So I'm just gonna go back and fix that. So I'm going to say this will be my F net. So the tensional force we minus my FG parallel, we're going to minus my FK, equate this to MA. What is the question saying? They want us to determine the angle of the slope. So now to determine the angle of the slope, this is what I'm going to do. I know that the tension, we already have the tension as 56.22. So I'm going to substitute my tension. This is 56.22 minus. So I think everyone in this lesson still remember that FG parallel is equal to what? Mass times the gravitational force. It's mg, the sine of theta. Please always remember that. So it's going to be mg. What is my mass? My mass is given as, for P. Look at the mass for P. It was given as 8 kg. Né? The mass for P is 8 kg. So I'm just going to write 8 kg here. This will be 8 kg. So this will be the mass of 8. We need to multiply this with 9.8. The sine of theta minus the frictional force that was given as 13.58. So the frictional force is 13.58 newtons. Let's equate this to MA. But remember, we know that the mass is 8. We know that the acceleration was given. If you still go up, the acceleration was given as 0.43. Né? So I'm just going to substitute this to be 0.43. So now the aim here is to isolate the sine of theta. So I'm just going to highlight that the aim is to isolate this so that we can solve for that sine theta. That's the aim. We need to isolate the sine of theta. So I'm going to work on it and isolate the sine of theta. So what I'm going to do is that, please guys, don't forget, né? Subscribe on the channel. Né? So now when I work on this, you need to be very, very, very careful. We're going to say, we take the 56.22, né? I'm going to minus that 13.58. I'm going to minus the 8 into 0.43. I'm going to equate this to positive 8 into 9.8, the sine of theta, so that I can divide this by 8, 9.8, divide everything here. The answer that you get here, né, you need to divide it by 8, 9.8. So what I'm trying to say is that you should get the sine of theta to be equals to, this cancels, the sine of theta should be equals to 0.5. When you punch that on the calculator, you should get 0.5. Guys, can you hear me now? Can you please confirm if you can hear me now? Okay, I'm sorry guys, I'm sorry. Let me quickly check the status of my network. I'm just gonna quickly check the status. The status is excellent, né? The status is excellent. But let us continue. Can you please confirm, guys, if there's something? Okay, what about now? Can you guys see the screen now? Okay, thank you very much. Let's continue now. Let's continue. Everything is good. So now look at this. If you punch that on the calculator, you'll get the sine of theta to be that 0.5. Okay, everything is good. Now how can we solve for theta? If I have sine theta to be 0.5, come on, this is grade 10. Eh? This is grade 10. We know that we need to find the reference angle. So theta will be equals to the sine inverse of that 0.5, which should give you 30 degrees. I still remember this. When I say greater than, I know half is 1 over 2. The sine of 1 over 2, sine inverse of 1 over 2 is 30. Therefore, theta is equals to 30 degrees. So they wanted us to find the angle of inclination, this angle here. So we know that that angle, we use it when we calculate the vertical, the FG perpendicular and the FG parallel. So FG perpendicular is equals to mg, the cos of theta. FG parallel is equals to mg, the sine of theta. So we know that this theta that we use here is the angle of inclination. When they want us to find the angle of inclination, so we know that we can use one of these formulas to calculate it. So if on your formula, on whatever that you are working on, you have these two guys, just make sure you work on it. That angle is the angle of inclination. I hope everyone is happy with that. Theta is 30. Thank you very much. So now, how can we calculate the coefficient? Because the question says, determine the angle, and they want us to find the coefficient of kinetic friction. So what I need you to do, I need you to write the formula of kinetic friction down. Fk is equals to Uk multiplied by the normal force. So now, we know that, guys, please, look at this. We need to find the normal force, and this object is uninclined. What is the normal force equals to? The normal force which point up, Fn, will be equal to the opposite force, which is Fg perpendicular, always uninclined. The normal force, you see, there's no force that is applied at an angle. We don't have any force that is applied at an angle. So this tells you that the normal force will be equals to Fg perpendicular. So I'm just going to say my normal force, Fn, it's equals to Fg perpendicular. And Fg perpendicular is equals to what? Mg, the cos of theta. So now, therefore, what is Fk? Fk is equals to Uk. Inside the bracket, I'll have Mg, the cos of theta. So what are we looking for? For the Uk, remember we know what is kinetic friction. They said that the kinetic friction, it was given as 13.58. So I'm just going to substitute this and say this is 13.58. Just going to put it here and say 13.58. Let's equate this to the coefficient of kinetic friction, which is the one that we are looking for. The mass is 9.8. The cos of that angle that we just calculated. So if the angle is wrong, this will affect everything. So I have 13.58, which is equated to the UK into 8 into 9.8, the cos of 30 degrees. So let's divide both sides by that 8, 9.8, the cos 30 degrees, divide. What you do on the left hand side, you also do on the right hand side. The cos of 30, and now we know that this guy here, this and that will cancel. We are left with UK. Now we know what is UK equals to. The coefficient of kinetic friction. And remember, it's a very small answer. It's going to be 0 point something. So it's 0 point. When you punch it on the calculator, it's very small. It's always 0 point something. Thank you very much. I really appreciate you guys coming in numbers. 0.2, thank you very much. Surprise. 0.2, I was waiting for the answer. So the answer is 0.2. The answer is 0.2. Are you all happy, guys? We're still going to work, guys. There's still more questions that we can answer based on this. There's still more questions, né? There's still more questions that we can answer. Okay, so now the next question that we need to work on, they want us, I'm going to work on this question here, which is number, that was 3. Let us work on number 4. You see, these are long questions. I always like to focus on long questions. Né? Number 4. Determine the speed at which Q strikes the ground. If you are in grade 12, this is a good question for you, né? Say, in physics we are not supposed to run off to 2 decimal places. I get it, they will give you like an instruction on the past paper that run off your answer to 2 decimal place or 1 decimal place, but most of the time is 2 decimal place. So you want us to write this coefficient of kinetic friction as 0.20. It's fine, we can write it like that, né? Okay, if you are in grade 12, congratulations. This question is for you, but even the grade 12s, né? So I'm going to teach you guys. This one is for you if you are doing an IEB. If you are an IEB learner and you are doing grade 11, you can also get this one. And if you are doing grade 12, this is definitely for you. But if you are in grade 11, please just don't pay attention on this question. I'm just gonna beat this one fast for the grade 12s and for the grade 11s that are doing IEB. Remember, in IEB you do kinematics in grade 11. Vertical projectile motion, you do it in grade 11. Okay, so now what we're going to do on this one, we're going to say that they want us to determine the speed which Q strikes the ground. Remember, Q starts with it starts hanging, then it will be dropped to the ground. What is that telling you? This one thing I need you to put in mind is that this tells us that the initial velocity for box Q is 0 because it starts at rest. Né? So I'm going to write this down and say the V initial for Q is 0. Then we need the final velocity, V final, the velocity that it will hit the ground with, and we know the distance that it will travel. We know the distance that it will travel. If we go back, the distance that will be traveled by Q, I know my drawing it's not exactly like correct, but just know that the distance that will be traveled by Q is that distance, which is 4 meters. So I'm going to substitute that as 4 meters. Then what else do we know? We know that the acceleration of the box, it will accelerate with 0.43 meters per second. Don't make a mistake and use 9.8. Né? Please do not make a mistake and use 9.8. So yes, guys, let's tap the screen. Né? Tap the screen. Maybe we might attract more viewers. Né? Yes. So now the formula, the best formula that we can use, it's a V final squared is equal to V initial squared plus 2A delta Y. I'm not going to say delta X but delta Y. Né? So if we substitute VF squared is equal to initial is 0 plus 2 into the acceleration is 0.43, and delta is 4. The answer that you get, we need to find the square root of that answer. So what I'm trying to say is that Vf squared is equals to 2 times 0.43 multiplied by 4. So when we multiply that by 4, what do we get? We get 3.44. We are looking for the velocity. We need to square both sides. The final velocity is 1.85 meters per second. Guys, I'm sorry, per second. Remember, if you are in grade 11, don't pay attention. But if you are in grade 11 and you are doing IEB, this question is for you. And if you are grade 12, this is also for you. Now let's go back to grade 11 and 12, the one that will accommodate both learners. Ne? I just wanted to show you that they can ask vertical projectile motions in Newton's law if you are in grade 12. I hope everyone is happy. I hope everyone understands what happened on that one. Ne? Yes, for question like this, you use equations of motions. Ne? Guys, don't tell me that the network is doing it again, guys. We still have 30 minutes to push. We still have 30 minutes. Oh, I think it's Kanisa's network. They say they think it's your network, ne? Okay, so from this question, they give us something. I'm just gonna give you guys the statement. I'm going to give you the statement, don't worry. So now, on the same object, we still have this angle as 30, and we still have this as P, right? And this is my X. This is my Y, and on Y we have this big guy going like this, right? So now this guy here is hanging, and then this is my Q. So they adjust the string. They adjust the string. They are now applying the string at an angle. So let's make this right now. The string is now pulled at an angle. Okay, guys, I'm not sure how I can draw this, but let me try. Hey guys, we have a problem. Okay, let me just try. Okay, there we go. So now the string is applied at an angle. Please guys, forgive my drawing now. The string is applied at an angle. So they increase the angle at 15 degrees. That's the new angle now. So what I'm trying to say is that the string is adjusted at an angle. Hey, guys, let's make this like this so that everyone can understand what is going on here. I just have to put this right. So this is my inclined, like this. We have box P. This is our box, and then they adjust this part, they move it up so that if the string can now be applied at an angle. Yeah, this is nice now. You see, the angle between this is 15 degrees. So I think this is nice now. Everyone can see now. And then this is Q. So the difference is that this time the string is applied at an angle. Yeah, so the string is applied at an angle. So we can see that from the diagram. This is my x, this is my point y. So the pull is adjusted so that the spring is pulled at an angle of 15. Determine the magnitude of the new force. The new force of friction. Determine the magnitude of the new force of friction acting on P. That's the first question. That's the question. They say that in this scenario, the acceleration changes. So the new acceleration is given as 0.5 meters per second. That's the new acceleration. So you may assume that the angle of the slope is 30. So the angle here is 30 degrees. And this is what we have now. This is what we have now. They want us to find the magnitude of the new force of frictional that is acting on the block. Guys, this is easy. Not only easy, this is nice. So look at how we're going to answer this problem. We're going to use crate P. We're going to use crate P. Right. We're going to use crate P. Someone can prefer to use crate Q. So we're going to use two methods. Let's start with method 1. We're going to start with method 1. Let's call this the first method. Then everyone will comment which method they prefer. So method 1, it has to do with what? We using crate Q. That's the first method that we're going to say the statement, please. Oh, the statement, listen, the statement, guys, the statement, they're just telling us now the new spring, it's applied at an angle. Remember that one was not applied at an angle. If we go back, the string was not applied at an angle. So the only thing that changed is that the new string is applied at an angle. Look at this. It was not applied at an angle. But this one, the new one, it is applied at an angle. That's the difference. So method 1, we're going to use crate Q. So I'm going to say F net is equals to MA. Because we are looking for frictional force, and we know that, wait, let's use crate Q. Okay, F net is equals to MA. Then, now, look at this Q. We need to identify all the forces that are acting on Q net. We have tensional force going up, then we have Fg going down. Right, so let's choose. Remember we set down as positive, down is positive. We set down is positive. Then we're going to take Fg, we're going to minus the tensional force, equate this to MA. So if we substitute, we know this is mg minus t, it's equals to MA. Then what is my mass? My mass is equals to, for Q, if you still remember, Q, the mass of Q was 6, and this one is 9.8, minus the tension, it's equals to 6, and the acceleration was given as what? 0.5, the new acceleration. So what is tension equals to? 6 into 9.8 minus 6 into 0.5. We equate this to tension, therefore you punch this on the calculator. Right. We punch that on the calculator, and what do we get as the final answer? So on my side, I have my answer as 55.8. So I have 55.8 Newton. That's my tension. Right. So if this is my tension, what's next? I need to indicate all the horizontal forces on Q. I'm not sure if you guys understand. So I need to draw a free body diagram indicating all the horizontal forces. So look at this. Remember, if Q is applied and then if the string is applied at an angle, look at this. This is my string. It's going up. This tells you that we're going to have Fx, the force that is horizontal to the surface. So this will be my Fx. Right. So if we draw a free body diagram, we're going to have an Fx going up. Then we're going to have the frictional force going down. Then we also have what? The Fg parallel. Very important. You see, guys, how this works. Thank you, guys, for your answers. Ne? This is how it works. Ne? So now that we have the tension, this is the tension that we have. We go to the other side. We're going to say F net for the other block. This is block P. Ne? This is block P. F net is equal to MA. So we take up as positive. So we're going to take our Fx, we minus all the forces that are going down. Equate this to MA. Okay, look at this. This is my tension, ne? And if this is my tension, remember Fx will be what? Will be applied force. If you still remember, Fx is just, let me write it down here. Fx, it's F applied, the cos of theta. But this time it's not applied force. It's tensional force. Is the tensional force. So this will be Fx is equal to T, the cos of that angle, the 15 degree. So it will be the cos of 15. So this will be T, the cos of 15 degrees. So this tells us that here we're going to substitute tension, the cos 15 degrees. We minus Fg. We know that this is unfortunately, we don't have a space. I'm just going to write it here. Fg parallel is equal to mg, the cos of theta. So this will be the mass. Remember, we are on P, and the mass of P was 8 into 9.8. Guys, space. Let's rewrite this now. Let's rewrite this. So this will be the tensional force, which is T, the cos 15, that's my Fx, minus Fg parallel, we said its mass, which was 8, 9.8, the cos, pay attention, this is a perpendicular, it's a component. Which angle are we using? That 30, so this will be the cos of 30. We minus, what are we minusing? The frictional force. Guys, space again, we made a mistake. Fg parallel is not mg, the cos of theta, it's mg. We made a mistake. Let us fix this now. We call this injury time. You see, when you're about to finish something, that's when this shows that now you are tired. We call this thing injury time. Ne? But guys, this is the last question. Don't worry. Please stay with me until we finish this question. Let's fix the mistakes that we made. Guys, someone is asking there, why are we using, why can we use T? I'm not sure if I understand. Okay, what I'm trying to say, Fg parallel, it's equal to mg, the sine of theta. Right. So, if we do the substitution, let me just fix this now. This will be Tx, which is T, the cos 15 degrees, minus the mass of 8 into 9.8, the sine of that angle, which is 30 degrees, minus frictional force, which is the one that we are looking for. The mass is 8, and the acceleration was given as 0.5. So this will be 8 multiplied by 0.5. So if you don't understand what is FG parallel, please remember it's the mass times the gravitational force times the sine of theta. Okay, so now one thing about this is that we know what is the tension equals to. We know what is tension equals to. We calculated tension to be what? We calculated tension to be 55.8. So I'm going to say this is 55.8 newtons at the cos of 15 degrees. We're going to minus 8 into 9.8 the sine of 30 degrees. Guys, I'm going to take the 8 multiplied by 0.5 this side to be negative, so that we say Fk is equal to that. Whatever that we get on our calculator is our frictional force. Last man standing. You see, the viewers are going down. People are tired. But this is the last question, guys. Say, when they say Tandegan, when they say magnitude in the answer, don't give direction. No, I'm not sure if I understand. Why can't we use T, tension, instead of mg? T instead of mg. Some of your questions, guys, are very confusing. Oh, my bad. I thought we used the previous one. No. Come on. Someone, we missed something. Please don't make mistakes, guys. 10.70 is correct. Monica is lost. Monica, which part? What's wrong? Therefore, Fk is equals to 10.7 newtons. That's my frictional force, guys. I'm going to show you. Maybe I should show you another method. But someone is lost. Monica is lost. Which part, Monica? Let me assist you. What's wrong? Remember, this is like simultaneous. We first focus on the first block, which is crate Q. We use crate Q to find tension. We use crate Q to find tension. Then we work on it. Oh, guys, let me attend FTBI. He's asking, why did we use T cos 15 instead of mg the cos of 15? Let me explain why. Where is this coming from? Ne? Let me explain, guys, where is this coming from? Let me quickly explain. So now I'm going to redraw that diagram. The diagram is like this. We have tension going up. So this is my what? This is my tension. And then now we're going to have a horizontal force, which is our Fx going down, and the angle between is what? 15. So we're going to create Fy going up. This is my Fy. They form a 90 degrees. So we can use and say we have T, which is my hypotenuse, and we are looking for Fx. So it's going to be the cos of 15 degrees. It's equals to adjacent over hypotenuse. Then we make Fx subject of the formula. What is Fx? Fx will be equal to T, the cos of 15 degrees. I think everyone understands. It's the same, guys, like saying Fy is equals to F applied, the sine of theta. Fy is equals to Fa. Fx is equal to Fa, the cos of theta. So the reason is that this is a horizontal component. Ne? Yes, the Fx is the horizontal component. Okay, now you get it, ne? He's saying, oh, okay. Hori, why you understand? Guys, remember on top I said method 1 using create Q. Let's use the remaining, please guys, make sure you subscribe, ne? Okay, we know what we're going to do. I'm going to remove this. I'm sorry. Method 1, we said we are using create Q. So now, you know what we're going to do. I'm not sure if someone will follow on what I'm about to do now. Ne? Method 2, the second method, we still use that create Q, but this time there are some of the things that will do differently. Remember, Fnet is equals to MA. So we need to indicate all the forces that are acting on Q. I always like to draw my free body diagram. I'll have tension going up. I'll have my Fg. So Fa we take down as positive. This will be Fg minus tension. It's equals to Ma. Let's quickly substitute. We know that mg is the mass, which was given as 6 multiplied by 9.8. It's equals to, oh, we are subtracting tension, right? It's equals to the mass times the acceleration, which was 5. Okay? So when we calculated tension, we got tension as what? We got tension as 55.8 newtons. No need for me to explain this again because this is what we currently worked on the previous right. Thank you very much. So this is what we currently worked on. So now what I'm going to do this time, I know that my frictional force, look at this, I know someone is going to prefer this method. So I know that my frictional force Fk is equals to UN, the coefficient times the normal force, right? So when we look at the one that is on, the one that has normal force is create Q. Look at create Q. You see, this is my Fn. So let's quickly rewrite this down. Let's quickly rewrite this so that everyone will get this right. Né? Let's quickly write this down. We have this on the inclined, which is my P. So the P will have, we have the tension that is applied what? At an angle. Né? So remember Fy will go up, right? Then we'll have the normal force going up, and then we'll have the Fg going down. So I don't want to waste time. We know that if the force, tension is also a force, né? I don't want to waste time. If the tension is applied at an angle, what did we say? Is pulled. What is the normal force equals to when the tension is pulled? The normal force is equals to this. If it's pushed, the normal force, but now it is on incline. We don't use Fg. We use Fg perpendicular. So what I'm trying to say is that this Fg here, this is your Fg perpendicular. It goes down. So when you draw a free body diagram, you'll say Fy going up, then Fg perpendicular going down. Then we have our normal force. So this is normal force. I'm sorry guys if I'm moving fast. That is normal force. Oh, the Amingo, thank you. The Amingo is saying that we are subscribing. No one wants to miss these lessons. Yeah, these lessons, guys, you're going to get all the help that you need as long as you move with me. Né? I try to move slow. I just hate explaining the basics a lot of time. You see now, we were just supposed to, instead of doing all this drawing, we're just supposed to say, oh, the force is applied at an angle. We just know that the normal force will be equals to FG perpendicular, then this will be reduced by what? By the FG. This is what we supposed to do. But now look at this. Look at this. Not FG, man. I'm sorry. It's not FG. Look at this. TY. We call this TY, the vertical force of TY. Let me erase this. I want to write it properly. Né? Okay. I just want to write it properly. Someone is saying my pace. It's fine. So I guess I'm not running. Né? So the force that will point up is TY, the vertical component of tension. So we're going to call it TY. So what we're trying to say is that the normal force here will be T, we're going to minus TY. And we know that TY is equal to the tension, the sine of theta. The tension, which is 5.58, the sine of that angle of theta we said is 15. Remember, this angle here is 15 degrees, so it's applied at 15 degrees. So this will be 15. So now if we go back, we know that my normal force, my Fn will be equals to mg, the cos of theta, minus tension, the sine of theta. So what I'm trying to say is that the formula that we can use is this one, because we know what is the coefficient. Remember, the coefficient was equal to 0.2 when we did the calculation. So what I'm trying to say is that to finalize this problem, we can write the problem in this way and say Fk is equal to the coefficient multiplied by Fn. You'll understand why we need to put the Fn inside the formula, the brackets. So this is the coefficient multiplied by, we said the normal force is Fg perpendicular, which is mg, the cos of theta, will minus t, the sine of theta. So now look at this. My Fk is equals to the coefficient 0.2, the mass of this, it was 8, né? And then 9.8, the cos. Remember, this is your Fg perpendicular. We use the angle of the incline, which was 30. We minus, we don't have a space, guys. I'm afraid I'll have to remove this free body diagram because everyone understands where is the forces that are acting there, the vertical forces. Okay, so now this tells me that this will be minus 55.8, the sine of 15. That's what you need to understand. When you punch that on the calculator, you should get the same what? The same answer that we did, then 10.7. So when I send this notes, I expect everyone to go through the notes. I'll send the notes now on the group. I expect everyone to go through the notes. Then when you are done, if you have any questions, you can take a screenshot, then send it to me. Then I'll definitely do a voice note to explain whatever that it is that you don't understand. And that's it for this lesson. This is where we're going to stop. This is method 1 and this is method 2. I'm definitely going to send the notes now on the group. So let's use this 4 minutes to accept questions. The remaining 4 minutes, let's use it to accept questions. Guys, thank you, sir. Guys, I need you guys to do a favor next time. Make sure that you tap the screen. The more you like, I think the more we attract more viewers, né? I think this also works like TikTok. Thank you, Fana. Thank you, Soli. Thank you. Behind the eyes, thank you. Thank you guys. And Olitando, thank you guys. I really appreciate you guys staying with me until the end. No question, just pure understand. Achieved. The Amingo. Thank you. Thank you, sir. Personally, I prefer method 1. I'll definitely come back. Yeah, I think method 1 it's good. Method 1 is good, but please, when I share the notes on the group, make sure that you review the notes, né? And I think we can celebrate that we are approaching the weekend. Sunday we get in, we do maths, né? Sunday we do maths. Thank you so much, sir. The lesson was great. Much appreciated. It's a pleasure, né? Sir, may you please normalize including direction on the solutions. Okay. You want me to write FK is 10.7 newtons down. I'll definitely do that, né? Because what Onalina is trying to say is that if I don't put directions, lower and you won't put direction in an exam. And maybe you might lose marks, né? Yeah, maybe this is what Onalina is trying to say. Sir, please put directions, Onalina. I got you. I'll definitely put the directions, né? No question from my side. Surprise. When you are always here. Thank you, surprise. Thank you, Zwanga. Zwanga, when you are late. You are late. Yes, we enjoyed just like you promised on TikTok. Yes, guys, we do nothing but the best. Eh? So now we're going to move on TikTok. We're going to be live on TikTok. We do maths. Eh? Let's go and get more followers by teaching maths. So yeah, let me just prepare your notes first. At the video, then we'll move to TikTok, or maybe we can just even go live tomorrow. But tomorrow I have to travel. Okay, thank you very much for attending. This is where we're going to end the stream. This is where we're going to stop the stream. Thank you very much. Ne? See you guys. Sharp. Under which topic for mathematics and which grade? We'll see that on TikTok. Ne?